So let me walk you through example number 1 here. They say, okay, let's suppose that we have some function f of x which is given by x squared. Okay, so what does that look like? Well, I'm just going to draw part of it here for you. It's always good to sketch out your graph and take a look at what you're actually working with. So the squared function, if we go, actually let me do this in the white color. Okay. So 0, 0 is clearly a point. 1 over 1 up is a point. 2 over 4 up, so 1, 2, 3, 4, right about here. 3 over 9 up, so 4, 5, 6, 7, 8, 9, roughly here, and then 4 over 16 up. Oops, that wasn't good, but whatever. You get the idea. Now what we're asked for, when they say find f prime at 3, what they're asking for is what is the slope of the tangent line when x is equal to 3. That's what this is asking. So what it's saying is if you went over to 3 over 9 up and you drew in your tangent line like that, they're saying what's the slope, and that's the answer to this. So f prime at 3 is the slope of the tangent line at x equals 3. Exactly what I just said above, right? Okay, so this exact idea. So how do we figure that out? Well, instead of just plugging things into a formula, I'm going to walk you through what's going on here. What I'm going to do is I'm going to take this point that I already know. This guy right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, close enough, okay, is 3 over 9 up. I know that 3, 9 is a point on x squared, right? Because if I take 3 and I plug it in here, 3 squared is 9. Now I need another point, an arbitrary point on the green line. And what I'm going to do is I'm going to take an arbitrary point on the green line and I'm going to squish it towards this point right here by using a limit. So let's take this guy right here. Okay, just like this. Now you might say, well, how far over is it? That part doesn't matter. Okay, so here's what I'm going to do. I'm going to go just a little bit over. I'm going to call that little bit over that I go delta x. So this guy is at 3 plus just a little bit over, like that. Do you see? So what I'm saying is that this length right here, that length, that's delta x. Whatever delta x happens to be. It could be 0.1, it could be 0.01, it could be 0.001, who cares? Okay, we're going to make this guy go to 0, and that, well, as we make this guy go to 0, this distance becomes super small, and it takes this point and pushes it towards this point right here. Now what is the height? Well, if it's at 3 plus delta x over, its height value has got to be f at 3 plus delta x. So we're going to take 3 plus delta x, and we're just going to plug it in here. Now we don't know what delta x is. Okay, so we're going to end up with some variables. So here's what we're going to do. We're going to take a look at the change in the y values. So this right here is the change in the y values, which is given by whatever the function evaluated at 3 plus delta x minus f at 3. And we know that this guy right here is equal to 9. So we're going to replace that in just a second. Then we're going to divide that by this distance right here. Well, this distance here at the bottom is 3 plus delta x minus 3, or just delta x. And that makes sense because that should be the distance. That's what we talked about. So the bottom down here is just delta x. Then what we're going to do is we're going to take the limit of this, as delta x becomes super small as it goes to 0. And that takes this point right here and pushes it towards this point right here. Okay, so how are we going to do that? Well, we've got to do a little bit of algebra here on the inside. So I'm going to go ahead and do some evaluating. So this would be the limit as delta x goes to 0 of, now I got to take 3 plus delta x and plug it into f. So remember how your function notation works. If I say f of x is equal to x squared, then f of something has to be equal to something squared. And so if I say what is f at 3 plus delta x, that's going to be equal to 3 plus delta x squared. So that's this guy right here. So we're going to have 3 plus delta x squared minus, now f at 3, we already know if we plug in 3 here, we get 3 squared, which is 9 out. So minus 9. And that makes sense, guys, right? Because that's the value that we got right here. Now we divide that by delta x. Now we can't just plug in 0 for delta x because it's in the bottom here. So what we need to do is we need to do this math out up top here and still simplify. So we have the limit as delta x goes to 0. Now I got to square this guy. Do not just distribute the squared in. We actually have to FOIL this. So that's going to be 9 plus 3 delta x plus 3 delta x plus delta x squared minus 9. And that whole guy is over delta x. That's my delta. So we've got the limit as delta x goes to 0 of the 9's cancel out, right? And what I'm left with is 6 delta x plus delta x squared over delta x. Now I'm going to factor out a delta x. I'm gonna write it, well, whatever, I'll write it right here. So that's going to be delta x times the quantity, 6 plus delta x over delta x. Now the limit as delta x goes to 0. This guy right here is going to be equal to the following. I can cancel the delta x's out because I know that delta x is not 0 because I'm taking the limit as delta x gets close to 0 but is not actually 0. So that's important that you understand the difference between those. So this is going to be just 6 plus delta x. And then of course the limit of this guy as delta x goes to 0 is just 6. And so the main idea here is the slope of this white line, the m value for the white line right here, is equal to 6. It is not the equation of that white line or anything like that. I just know the steepness of this white line right here is 6.